All right, so our presenters today is Dom, and then later for the second half, Josh will be coming in. Yeah. Wait, let me check the audio is working before I fuck up the recording. No, we're okay. So yeah.
Can you make a presenter view so I can see
Yes. Where is it? Fuck, view? Oh, presenter view.
Yeah, just so I can see the next slide coming.
Can you do it on your iPad?
It's not loading.
What the fuck?
I'm waiting for it. That's alright. I can do it here.
Put it on my phone if you want.
That's okay. So yeah.
Is that how it works though? Because they can just see what you can see.
Oh, is it?
Thing.
Oh, okay.
Dumbass.
Sorry. Been working on site for a long time.
Anyway, so while he's getting that ready, everyone give him a round of applause. This is Dom.
Can you load it on your thing actually?
Yeah, I'll get on my phone.
Yeah.
Just
Okay.
start on
Alright, so welcome to 2101. My name is Mosen. We're going to be doing a crash course for today. So on the left, you can see that Mosen was on a site the other day. I think Henry was there during, what was it, the high school
Yeah, it's like a work experience.
program, yeah.
Yeah, it is.
And there's a couple other site elements that we'll learn about. So the Portaloo and then the Coates Hire portable office. Okay, anyways, onto the actual stuff. So I'm going to be doing weeks 1 to 5 content, but we're just going to touch on concreting and earthworks for the in-depth part of it. And then I'm going to go through the assignments and then also the midterm. Okay, so demolition, you guys would have gone through it, right? I'm just going to briefly just run through what demolition is. So demolition, you're basically trying to break down some sort of structure, right? Dismantle it. So the demolition process is usually has a lot of paperwork, and then you decommission the buildings to get all the, the electrical lines, gas lines, water lines, and then you break the shit, all right? Demolition methods, top down, high reach arm, wrecking ball, implosion, and induced collapse. And then demolition safety, just PPE and, making sure the site is separate and not dying, basically. Okay, all right. So before we go into earthworks, I just want to draw a small diagram. Okay.
It's not loading, bro.
Oh, fuck, okay. All right, so basically on any piece of land, right? Right, so this is, let's say the land. Oh, fucking broken the chalk. Okay, there's gonna be like trees, and there's gonna be like hills and stuff like that, right? And then maybe even buildings, right, that are pre-existing. So let's say I'm infrastructure for New South Wales and I wanted to build something new on this plot of land, right? So these are all, this is an old building that we don't use anymore, and we have trees and undulating terrain and stuff like that. So we have these hills and we want to kind of get the land ready to build something new, right? Let's say we're building a metro station or something. I don't know if that's ever been thought of. So we would first want to make sure the land's flat, right, before we can build anything on it, right? So what would be the first thing we want to do? We want to actually get rid of all the old buildings first, right? Because the landscaping we can deal with after, but we want to make sure all the buildings are just clean and gotten rid of, right? So this first part, when we get rid of the buildings, what would that be? That would be demolition, right? So we go through that demolition process, we break down all the buildings, and then once all the buildings are gone, basically, we're left with, trees, hills, right? And we kind of want a flat surface that trains can run on, for example, right? So this second part, when we get rid of all the terrain and flatten it and do the landscaping, that's called earthworks, right? So that's what we're doing for this first part. After that, after all the earthworks is done and all the land is flat here, the thing that we do after is usually concreting, right? And concreting is usually we're building a foundation out of concrete so that we can actually build a building on top of it, right? Because we can't build it right on the soil because soil moves a lot, yeah? Okay, so for this first part of earthworks, we're just going to talk about what it is, right? So earthworks is manipulating the land or shaping the earth to fit our construction needs, right? So every site, no matter where it is, will need at least a tiny bit of earthworks, right? So even if you're doing, let's say you're building a granny flat in the backyard, right? The earth there may just have a slight gradient, and that's not good. We want to make sure it's flat, right? Or we want to make sure the slope is a certain direction, right? So every single site, no matter how small or how big, will need some sort of earthworks. So the picture I have here is a pretty big site. You can see that it's just huge amounts of dirt there, and they're just moving it somewhere else. Okay, so equipment for earthworks. So there's a couple different types. So excavators and loaders. So what an excavator is, it's basically a big arm that can reach and dig up dirt and water and stuff like that. Right, so on the left here, we can see that this excavator is digging out a big trench, right? It can dig it out a lot faster than a human can. So it's a big bucket and it's hydraulically powered, right? So it can dig up and then move the dirt. The second one here is a loader. So what this loader does is, for example, you can see the pile of dirt on the left there. What that loader can do is it can take that dirt and put it into a truck, right? Now, an excavator can bring the dirt and put it directly into a truck, but if there's heaps of dirt, we actually want to minimize the amount of time that the excavator has to use to put that dirt into the truck. And you'll learn about it with Josh when he goes through the actual formulas on calculating efficiency and the speed of how much earth an excavator can move. But yeah, typically on a larger site, they will use a loader as well. Okay, so next pieces of equipment, these are dozer, truck, and scraper. So these pieces of equipment move and kind of flatten earth, right? They kind of push dirt around. So dozers, they just have a big kind of spade at the front, and when they just move, they just dig up all the dirt and plow it up as they go, right? So they just dig up the dirt and just move it. They push it to some place. A truck is used for holding dirt, and then that dirt is then transported to somewhere else. So usually off-site, or sometimes it's just put onto a side of the site that is not used right now. And a scraper. Scraper is kind of like a dozer and a truck combined. So it can actually hold a little bit of dirt, not as much as a truck, but it can hold the dirt and kind of drop it in other places. So what a scraper does, it kind of does what a dozer does. It digs up, it plows up that land, and then it kind of takes a little bit into its storage bin. You can see in the middle here, and then it can drop it wherever it needs. So yeah. Okay, roller and motor grader. So these are for finishing land. So what these do, so the roller compacts the land, right? So it's a big heavy drum, and it vibrates and it just rolls along and compacts the soil. Make sure it's really, really hard and ready to pour concrete on. And then motor graders are similar to that, but they can turn a little bit more easily. And they also just scrape the dirt along and kind of level the ground. Okay, so machinery. So let's just classify all these, right? So excavation and loading, this is actually just digging up the land. And you think of this as foreplay. The kinds of equipment that we would use is excavators, loaders, and loaders. So we basically are just getting the dirt kind of moved into certain sections. This is like a bulk amount of movement, right? Next, we have penetration, or pushing and hauling. So that's basically the dozer, the truck, and the scrapers. They're trying to push dirt and move it somewhere else. And then we have ejaculation, which is finishing. So that will be the rollers and motor graders, which kind of flatten the land. Okay. All right. Okay. So basically, that is the kind of stuff, that's the kind of equipment and stuff that happens on site, right? So when we do the calculations, this is what we're gonna have to do, right? So when we move the dirt, yes, we can move it, but we also want to calculate, okay, well, how much can, our truck carry and whatnot, right? So these are the types of calculations. So in general, for soil characteristics, high moisture is bad. So think about like standing on wet sand when you're at a beach, right? You're going to start to sink through, right? So you start to fall inside of it. So think about a truck now on a beach, right? It will actually get beached. It will fall into the sand, right? So moisture content is basically the amount of water to the amount of dry soil, and then you calculate that as a percentage. So yeah. Okay, this is more important. So this is for calculations later on, but you will do a lot of calculations in these kinds of units, I would say. So bank, loose, and compacted. So make sure that when you're calculating with the right kind of thing. So the units here are all different, and they all mean different things. So bank is the material in its natural state before disturbance. So basically think about a hill that's full of dirt. You can climb on it, you can run on it. That's pretty compact, right? So you dig it up, right? So that's bank that you're taking out, right? Loose is what happens after you dig it up, right? So imagine taking a trowel and digging up at soil, right? The soil kind of aerates and it has air bubbles in it. So it takes up more volume, right? Now, when it takes up more volume, right, we can't carry as much, right? So we're calculating in volume right now. So from the bank, we take it up, we put it in a truck, it becomes loose, and then compacted is a separate one. Compacted is after it gets flattened by like a roller or a motor grader, right? So this is what happens before we finish the land, and then it shrinks basically after that because we take out the air. Okay, so the first part is bank soil. So swell is so after you dig up that soil, the air goes in, right? We get swell, and that's just the loose volume over the bank volume minus 1, and then we multiply that by 100%. I don't know how that comes about, but just trust me. I'm sure the tradies know what they're doing. So yeah, and then the load factor. This is actually the more important thing. So you use, usually they will give you a swell percentage, and then you have to figure out either loose volume or bank volume. And then you're gonna use that to do the load factor, basically. So load factor is basically how much you can put on a truck, right? Because it would cost you more if the truck had to run more times to carry the same amount of dirt, right? So we want to pack it on as much as possible, right? So the load factor is just how much we can put on a truck. We want to put more and more if possible, increase our efficiency and our KPIs. Okay, shrinkage. So this is the opposite, right? So this is like a penis in the winter. So it shrinks when we force the air out of it, right? So the granules become more tightly packed, right? So we're taking out that air, it becomes more tightly packed. Happens when we compact it, right? When we roll something over it. So shrinkage equals 1 minus compacted volume over bank volume times 100. And then we have the shrinkage factor as well, and we've got the formula for that. Okay, does anyone have questions about that before we get into other parts? So we understand swell, shrinkage, yeah? Yes, okay, cool. All right, so volume estimation. Okay, this is a topic that is kind of theoretically easy to understand, but it's really easy to mess up in a calculation, okay? Now, I'm not gonna go through the calculations because we'll be here until tomorrow, but I'll just go through the general gist of how these work. So cross-sectional method is our first method, right? Now, think about this as a 1D method. It's usually used for things like highways and really long, like kind of runways and stuff like that, right? Because when we have a, let's wrap this out. When we have a long road, right, usually all our roads are quite flat, right? So just take this as a cross-section. There's a cross-section of our road. Now, before we build on a road on it, there's going to be land that kind of has hills and valleys, right? Now, some are going to be higher than others, some are going to be, deeper than others, right? So what we want to do is we want to level this land, right? Now, the cross-sectional area is going to basically take this 1D section, and it's going to move dirt from the high areas to the low areas, right? So we want to fill in all the low areas, and then we want to get rid of the high areas, right? And then after, once it's done, it should be nice and flat. Okay. So a couple areas and stuff like that. It's just volume of trapeziums and stuff like that, basically. So it's not too difficult, but yeah. So yeah, this is the road profile I was talking about. So if we had a road profile like this, we want to get rid of all we want to cut. This is what we call cut. We want to cut all the high places off. We want to fill in all the bottom places. So yeah, you'll learn about cumulative mass diagrams, and I recommend you do study that for the midterm, because usually there's always one of those in there. And basically, it's just talking about where we're going to move the land, basically. So yeah. We'll go through it more in detail. Okay, grid method. Actually, anyone have any questions on the cross-sectional method? No? Okay. Grid method. Okay, grid method, instead of 1D this time, we're going to think in 2D, right? So the grid method has a square or some sort of shape, and then we're going to divide it into equal sections. Right? I'm going to divide it into equal sections, and then you take each of these nodes, right? And all it is basically you're taking dirt from around this node and you're kind of spreading it out to make it all level. Okay. So you're just taking the height of each node and you're trying to flatten it. And there's formulas to do that. And Mosen's pretty good at teaching this part, so I wouldn't worry too much about it. But yeah, just think about it as 2D for grid method. And then this triangular prism method, I think Mosen put this in the midterm last year as well. He goes through this in pretty good detail as well. But this one's basically for taking an irregular shape, and then you're just dividing all the shapes into triangles. Right? So it's called a triangulated irregular network. And then you're just taking a center and you're just dividing into triangles. And you're moving dirt from one of these triangles to another to just flatten the land. So yeah, the same principle applies with all of them. Grid method, triangular prism method, think about it as 2D. And then for the cross-sectional one, just think about it as 1D. So yeah, okay. How are we doing for time, Henry?
How much of your slides have you gone through?
Not half, yeah.
About half?
Not half, yeah. 40?
Oh, you're going like on time.
Okay, cool. All right, soil classification. Okay, there's a lot of detail on these slides that Mosen goes through. All you need to know is that A, B, and C are in order of strength, right? A is going to be the strongest, C is going to be the weakest. Okay, that's what I would take note of in this. So A is strongest, B a little bit less strong, and then C is weak. Okay, so why do we need to know about this kind of soil classification? Well, we need to know about this soil because there are different ways that we can kind of protect ourselves from soil collapsing. So think about a sand dune, right? We can only build, or a sand castle actually, you can only build a sand castle so high before it starts to tip over, right? Imagine you're building it out of dry sand, right? When you start putting more and more sand on top, when you sprinkle it, it's going to start falling off the edge, right? Or the side, yeah? So what we need to do is we need to figure out, okay, well, how strong is the soil? And then what angle can we actually put it at, right? Or different other methods we can use to stabilize the soil. Because we don't want soil to move when we're kind of mining or excavating or building, because that would be very, very bad, right? It could cause catastrophic failure. So ways that we can actually protect ourselves, right? So we need to know the soil characteristics to be able to use a protection system that makes sense for it. Okay, so there's 4 kinds of protection systems. We'll go through all of them today. Sloping, benching, shoring, and shielding. Okay, now we'll talk about the first 2 kind of as a pair because they're done in more kind of rural areas. You would see these more in like mines and stuff like that where they're a lot further away because they take up a lot of space, right? You can see the sloping takes up not only vertical space, but it takes up that horizontal space as well. Benching, the same thing. Whereas shoring and shielding, you can see it's straight vertical, right? So you can cut out land like in Minecraft, basically. You just dig out a 2x1 block or whatever, right? So sloping, right, is literally what it is, right? So it's like, it's some sort of hill and it's just the slope, right? And the angle that we can have the slope at is determined by the soil type, right? But basically, this angle here, I think it's alpha. Yeah. Yeah. This has a maximum angle based on what kind of soil it is, right? So you can think about it as, okay, A type soil, right? It's going to be the strongest, right? So you can have it more vertical compared to C type soil, right? It's going to be a lot weaker. So we can't have it as a steep angle. And yeah, and B is in between, is 45. Okay. Anyone have any questions about sloping? Okay. Feel free to interject, Henry, if you have any questions.
Just a quick note as well. You'll send over these slides later as well, right?
No.
So if anyone's like copying stuff down and you miss it, then...
Yeah. I think listen to what I kind of explained more because these slides are a bit cooked.
And of course we have the recording going on.
Yeah.
So you can
Yeah.
check that.
Yeah.
But does it feel like it's going too quick or too slow?
Too quick, too slow? This is okay. Okay.
It's hard because you have to help people who are writing stuff down. As well.
Yeah, exactly. Yeah. Okay.
You're in a good pace.
All right. So next one, right? So sloping is our first one. It's the most simple one, right? Benching is our second kind of one, right? So it's like, think about Minecraft. You're kind of jumping up the steps, right? This is what benching is like, right? So we determine the height of each bench and the length of each bench based on the soil type as well. Now you can see that on the slides here, I only have soil type A and soil type B. It doesn't actually work for soil type C because it's too weak to bench, right? So think about this this here, a bench here, the soil here is going to want to collapse that way, right? It's going to want to fall over, right? So it's going to want to fall over into this side. Now, soil type A and soil type B, they're going to be strong enough to kind of hold themselves vertically for 1.5 meters and 1.2 meters respectively, right? But soil type C is too weak to hold itself upright, right? So it's just going to collapse. So we don't do it for soil type C. So benching only soil type A and B. And you can see the gradients are actually the same as well, yeah? It's just that we're benching to save a bit of space. So yeah. Okay. Shoring. Okay. Shoring is when it's used when sloping and benching is impractical. Now, when is it impractical? Usually in urban areas, tight spaces that we can't actually make a bench or a slope, right? Now, these are going to be more expensive because it's going to require precast concrete to be shipped onto site, or concrete that's cast onto site on site as well. And we'll go through that. Yeah. But yeah, it's basically a vertical wall. So you're building, you know, you're digging out some sort of ditch here, and you have some shoring along the walls here, right? So you're gonna have shoring vertically like that. So it doesn't allow the soil to collapse on the inside, right? Because there's gonna be concrete holding it back, yeah. Okay, so common shoring methods: soldier piling and lagging, sheet piling, soil nailing, secant or tangent piling, and diaphragm walls. I don't know why, but Mosen covers this part in a lot of depth, but it's not usually in the midterm. Like, it's not heavily covered in the midterm for some reason. But he might change it this term. So yeah, don't trust me on that. yeah. Basically, we're just building something upright to hold back soil. Okay, earthworks, soil protection system. Okay, we're going through shielding now. So shielding is something that's a bit more temporary, right? So it's going to be something that allows just a small number of workers to be inside the kind of shield, right? So there's going to be, you know, one worker inside there doing, I don't know what they're doing, but they might be doing some wiring, they might be doing some plumbing, whatever it may be. Shielding is like shoring, except it's temporary. It's just a metal bin, basically, that they drop down into the soil, and that just stops it from collapsing inwards. So yeah, it just creates a safe space. Yeah. Okay, concreting. It's my favorite part. Okay, so back to that initial diagram. So we got rid of the buildings through demolition, right? And then we got rid of all of the trees, the land, through our earthworks, right? Now is onto the good part, the concreting, right? So now that our land is nice and flat, we want to pour some sort of slab on top, right? So we want to pour some sort of concrete. So then we can build our new buildings, right? And build our new buildings. Yeah. Okay, there we go. So this concrete slab is the next part we're going to talk about. So first of all, what is concrete? So concrete is like man-made rock, basically. It's our version of rock that we can shape into whatever we want, right? So you've probably seen, you know, concrete cast into different shapes and, you know, curves and stuff like that. We can do that with a lot because concrete is like a liquid, basically, almost. We can just shape it into whatever shape we want. Yeah. So concrete is made up of cement, small aggregate, large aggregate, and water. So basically the cement, you'll learn this more in concrete, but cement is basically limestone that's been like baked in a really hot oven, and then that is what is called clinkering, and then they just crush it up and then make cement out of that. So basically it's just powder, and then you add water to it and it reacts with the water and becomes a paste. That paste is then combined with fine aggregate, so usually like sand, that becomes like mortar, which is what they put in between bricks. And then if you add coarse aggregate to that, then it becomes concrete, right? Okay, anyone need to copy that down? Okay, you guys a minute.
Just learned that, the week one of concrete.
Huh?
You just learned the week one of concrete, right?
Yeah, I learned that from the conversations with you.
Oh, okay, yeah.
Concrete is my favorite mixture. Okay, cool. All right, so when we pour concrete, there's something called slump, right? So slump is basically how much the concrete kind of spreads, right? So what is a slump test is like basically a bucket where they pour concrete into and then they just lift it up, right? And then you'll see how much the concrete kind of spills out, right? Or kind of sags, right? So you can see that this concrete here has a high slump, right? So it's slumping a lot. So it's spreading heaps, right? So think of slump as spread. So it's spreading a lot. And when it spreads a lot, that means there's usually more water, right? And more water means it's lower strength, right? Compared to something that is a low slump, it will stand up a lot taller, right? So when the concrete stands up a lot taller, it's going to be a lot higher strength when it cures. So I think you will need to learn about this diagram. So this diagram is basically just how much water and what strength the concrete has based on the slump. So yeah, you can see that more water means it's going to be a lot weaker. So yeah. Anyone have any questions about the slump test? Okay. Yes?
Why would you want it to have higher slump?
Higher slump? Oh, so higher slump means it's more liquidy, right? So usually higher slump is easier to pour, right? So it's going to be easier to work into different like shapes, right? Imagine something that's a lot drier, trying to pack it into a wooden structure, right? Or a formwork. It's going to be pretty difficult, right? So trying to pack it into a shape, liquid's going to be easier, right? Think about pouring water versus trying to like pack coffee grounds into the bottom of a cup, right? So that's what I would think about as. This is something that you'll learn on site, but a lot of concrete trucks or a lot of pumpers will try to add more water into the concrete, and that makes it less strong. It makes it a lot weaker, but it allows them to pour it much quicker. So that's the reason they do it, and it's usually not meant to be done. There's a tolerance for the amount of water, but you're not meant to add too much water. So yeah. Okay, so usually we don't just pour concrete just onto the formwork. Usually we pour concrete onto some sort of rebar, right? So rebar is a type of reinforcement. It's basically like steel, right? So steel that's laid across the concrete in a lattice shape. So what they'll usually do is once they have that land flattened, right, and compacted, they'll put some sort of coarse aggregate on top, like gravel. They'll compact it again. They'll lay rebar on top, and then they'll pour the concrete in. Right, so that just makes sure that it's a lot stronger. So concrete is a ceramic, and that means it's really, really strong in compression, right? So when you push down on concrete, when you put a truck on top of concrete, it's not going to crack as easily as when you try to rip it apart, okay? So tension is the weakness of concrete. Now adding rebar into it increases its tensile strength. That means the concrete is going to be a bit stronger in both. It makes it a composite material. So yeah. Okay. Oh yeah, concrete placement. Sorry, I forgot to get rid of that text. Basically, this is how a pour day would work. So that's what they would call it on site, a pour day. So this is when all the concrete trucks come, all the pumpers come, and they kind of lay the foundation, the concrete, right? So you would have some sort of truck, an agitator truck, basically. Looks like this. Kind of looks like that. It's going to pour the concrete down, and usually it pours it into a machine that kind of mixes all the concrete up again, and then it pumps it, right? So into a boom pump. So you'll have some sort of truck here, and then that will kind of boom the concrete over to where it needs to be poured. So let's say they're pouring a concrete slab in the corner here. It's not practical to move the truck all the way into the site, right? So usually what they do, they pour the concrete into a machine, and that pumps it over, right? And that allows the workers to pour it down here. Okay. So usually what happens is they'll order the concrete about 2 weeks in advance, right? So usually Boral is the company that we go to. Hanson, if it's what we call shotcrete, but we won't learn about that today. So Boral truck will come, and that has concrete in it, right? So that has the liquid concrete, and you'll see it spinning, right? So that's just agitating, right? It's called an agitator truck. It's agitating the concrete to make sure it doesn't cure too quickly, right? So that when they agitate the concrete, they bring it to site, and you have about 2 hours of a working window, okay? This concrete gets poured into the pump, or into a machine, then the pump, and then the pump carries it all over to the work site, and then you pour the concrete, and then you're done, almost, right? Then you have to finish it, and then you have to make sure it cures properly. So that's how it works. So after they place the concrete, they'll vibrate it, right? So they'll vibrate. Oh, wait, sorry. Yeah. So the two types of pumps, and then they'll vibrate the concrete, and then they'll make sure it works properly. So the two types of pumps here, we have a boom pump, which is used to make it like transport it a large distance, usually up higher or somewhere a bit further away, and then a line pump, which is like a flexible hose. Basically, it's a rubber hose. So yeah, they vibrate this concrete for 7 seconds in each section, and what that does is it minimizes the air bubbles in the concrete, right? So what happens if we have air bubbles, right? It's going to be a lot weaker, right? Has anyone had like chocolate mousse? Chocolate mousse, right? It's a pretty fluffy texture, right? And it collapses straight away in your mouth, right? So think about that. When your car's parked on it, you don't really want that to happen, right? It's going to crumble, right? So what we want to do is vibrate all the air out of it, get all of the bubbles out, and then it's going to make it a lot stronger, right? So less air bubbles means stronger concrete. So if it's not vibrated enough, it's going to have air, it's going to be weaker. But if it's over vibrated, right, it's vibrated for too long, there's something called segregation that occurs. And we're going to go into that. It's a concrete defect. And usually when that happens, when it's over vibrated, you need to get rid of it. All right. So once that dries, they're probably going to have to dig it out. Okay. And then concrete finishing is just making the surface really pretty. So usually they would what we call screed the surface. They're kind of just brushing over it, making sure that it's all nice and flat. And yeah, just making sure that it's nice and pretty. So usually this is like pavements, and also even in buildings, they make sure it's nice and smooth and whatnot. So yeah. Okay. Concrete curing. So this prevents the concrete from cracking, right? Now, I feel like a lot of people think that concrete requires like moisture to be evaporated to cure, which is true, but we can't let too much moisture evaporate, right? So I'm just going to draw a concrete slab, and I'll go through why we don't want too much moisture to evaporate all at once. So this is a cross section of a concrete slab, right? Let's say the concrete was, I don't know, however much thick, right? It's a fairly thick piece of concrete. Now, when we pour it in, that concrete is going to fill up the whole place. But where is the moisture going to evaporate from? It's going to evaporate from the top, right? It's going to evaporate here at the top. So if you leave it out baking in the sun, right, that top bit of moisture is going to evaporate a lot quicker than the inside, right? Think about a cake when you're baking it. The top's going to cook first before the inside, right? So we want to make sure that concrete kind of dries or cures at the same rate in all places, right? So what they'll usually do is they'll pour water on top, or they'll spray it with water. You can see here, these guys are spraying it with water and then moving the water along so it's nice and even along the concrete. There's another type of concrete curing method called ponding, where they literally put a bed of water on top. And that happens, that's like good for like really dry environments and whatnot. But yeah, that's concrete curing. Okay, cool. Concrete defects. So, first type of defect, segregation. So segregation is not very good, usually because it happens because of the wrong large aggregate size, right? So imagine like it's, what would I say? It's basically when the aggregate is too big, it's going to be a lot denser than the rest of the mixture, right? Remember, concrete, as I said, we need an agitator truck. Why? Because it doesn't mix like a smoothie. It kind of sinks to the bottom and splits after a while, right? So yeah, concrete is made up of a couple different things, and when they mix it all together, it shouldn't segregate, but it may segregate because of aggregate size, but also because of over vibration, right? So imagine you're trying to shake it, and then all the heavy stuff will fall to the bottom, all the light stuff will float to the top, right? Or because of a high slump. Now, why do we think a high slump might affect the concrete mixture? Open to the whole class. Yes?
If it's really low viscosity, there's a certain water in it, all the heavy stuff's just going to go straight in.
Yeah, exactly. All right.
Stopping it.
Yeah, exactly. It's like putting rocks in water, right? Yeah, so the rock's just going to float it's going to go to the bottom. There's nothing kind of keeping it all together, all mixed. So yeah, exactly. Yeah. So if the concrete segregates, we need to get rid of it. So they need to demolish it and redo it, usually. Cracking is also not good. So it happens when moisture evaporates too quickly from the surface, right? So you can imagine when you're baking a cake, same thing. If the moisture evaporates too quickly from the surface, the top of the cake's going to start cracking, right? It's going to dry out way too quickly, and it's going to start cracking, creating defects on the top here. So I think it's called plastic cracking something, but yeah, basically cracking. Okay, anyone have any questions about concreting? This is my favorite topic. Anyone have any questions about concrete? No? I'll touch briefly on what admixtures are and special types of concrete. So admixtures are basically just adding a little bit of some sort of liquid. It just is an extra bit of stuff that helps the concrete take on some sort of new characteristic, right? So you can add admixtures to slow down curing or speed up curing. There's also ones that kind of like, basically let it evaporate less and whatnot. So yeah, there's just stuff you add into the concrete. But yeah. Special types of concretes, your reinforce is going to be the main one you're going to be talking about, high strength concrete, stuff like that. There's also no vibration concrete or something, where you don't need to vibrate it, but that sounds really dodgy to me and it's probably not used very often. So yeah. Also, I talked about shotcrete before. So shotcrete, I'll show you just a picture. Is this still recording, Henry? Yeah. Okay. I'll just show you a picture of shotcrete. Shotcrete is basically like sticky concrete that they spray, right, instead of pouring. So usually they spray it onto the sides here, or in a tunnel, they'll spray the roof with concrete. So they'll put bolts in it and then they'll spray the concrete over top. And that just basically just helps the roof kind of hold. So yeah. Yeah, usually they have someone who sprays it, or like a machine here that just sprays the concrete out. But yeah, there's a lot of tests for these types of concrete. So I'll just run through what a pour day would look like again. So first of all, 2 weeks out, you need to order the concrete, right? Borrow truck, make sure you order the concrete, get the pumpies in place, make sure they're all gonna come on the day, right? Make sure the weather's really good on the day, right? You can't pour concrete in the rain, despite what many think. It has to be nice and dry, usually sunny conditions, it's good for pouring concrete, right? Make sure the temperature's right. If it's too hot, what's gonna happen? The concrete's gonna start to crack because the moisture's gonna evaporate from the surface too quickly, right? So you don't want a cold day, we don't want a hot day, right? We want it to kind of be in a Goldilocks zone, and you will learn what that temperature is. After you pour the concrete, you need to screed it and make sure it's nice and flat and nice and smooth. Oh, actually, sorry, forgot one thing. Vibrate it. You need to vibrate the concrete. Make sure the air comes out, right? And then you screed it, and then you pour water on it after a little bit. So yeah. Okay, that's concreting. Okay, assignment time. Have you guys picked all your groups? Who here hasn't picked a group? Okay, cool. All right, so you guys have already gotten the brief for the first part and the second part, or just the first part? Both? Yeah, okay. So basically groups of 3, you guys need to find a construction project that is under construction currently, and then select 3 pieces of construction equipment, and then identify 3 processes that are linked to it, right? Visit the site at least 4 times, viewing from public areas and not inside. And then the minimum cost of construction has to be $5 million, right? Is that still the same brief for you guys? Anything different? No? Okay, cool. So yeah, tips, pick a team early. You guys have already found your team. Pick a project that's easy to access physically via PT or other means, and has a lot of information online. And then write notes on your site visits as soon as you get home. Don't leave it to the last minute. I've done it before, it sucked. So make sure you write all your notes as you go, or else it's gonna pile up and you're gonna forget details and it's not gonna be as good. But yeah, keep like a site diary of sorts. So yeah. Okay. So the assignment, we've gone through all the pieces of equipment that are here, and we've gone through some of the processes. Does anyone have any questions about the other processes, like scaffolding or formwork, piling, false work, anything?
This is Josh.
We might have a bit of...
You should be here soon.
Okay.
But wait, quickly.
Yeah.
For the concreting part,
Yes.
do you know what kind of questions they're expecting for that? Is this just volume?
concreting is usually volume calcs. Yeah, and usually like when you build a retaining wall, how much dirt you can hold back, basically based on the thickness and whatnot. I wish I could open the paper, but yeah, it's not very difficult for concreting. It's not going to be any structural information or anything like that. It's usually just volume. So yeah, but yeah, we'll go through the midterm in a second. Yeah, but yeah, a backhoe. So there's just a few types of equipment here that we haven't gone through. So backhoe is basically an excavator and a loader in one. So one side has a loader which you can load the dirt onto, and then one has an excavator which can dig up the dirt. And then compactor and roller. The difference between them: roller is like a car. Basically, you actually need to drive it, and then it just flattens the land. Compactor is usually just a one-person machine. They kind of just hold it and walk along, and that just vibrates and compacts the dirt as they go. And then boom pump just transports concrete, moves concrete from somewhere to somewhere. So yeah. Okay. Wait, anyone have any questions about the assignments so far? Have there been any concerns with the assignment? Have we all picked sites yet? No? Okay, I might go through. Okay. All right, good places to find sites would be infrastructures. So infrastructure New South Wales. So I would say infrastructure. Yeah. So I just searched up this, and then you have the major projects hub for transport, and then you also have the projects New South Wales. So you can have a look on this, and it will give you a good kind of range of things. So at the moment, I would say that since you guys are going to do 3101, probably, are you guys doing 3101 at the end of the year? Anyone doing it at the end of the year or next year? End of the year? Okay. It might be good to do Sydney Fish Market, but that finishes 2025, or it's expected to, but I don't think it's going to finish on time. So you could pick that, because what happens is in 2101 and 3101, it's kind of linked. So if you do your assignment in 2101 on a site that is still in progress for 3101, you can actually use a lot of the information that you did for 2101. So I would recommend trying to find one that finishes maybe 2026 or something, so that you can use the information. You don't need to research twice. So yeah.
Sydney Fish Market's also a good one because it's fairly open, so you can take pictures from like a bunch of different angles.
Yeah.
It's not as hard as Sand Tunnel to like take pictures of.
Yeah. So I did Fish Market for 3101, but I wasn't smart enough to do it for 2101, so I didn't think about that. 2101, I did one of the metro stations. I can't remember. I think it was Ultimo Metro Station. But yeah, that one was terrible because it didn't have very much space and like places to take photos of. So yeah. What would be good ones? Blackwattle Bay is okay as well. You can take photos from there as well. Penrith Station, I guess if you're from that area. But it's a very far trek for most people, I would say. But yeah, try to go with your group as a... Sorry?
No,
okay. Yeah, but yeah, I would recommend Sydney Fish Market. If you guys all do Sydney Fish Market, that's fine. It's really, really good. Yeah, as Henry said, really easy to take photos. You can visit it basically just outside and take photos of it. They are finishing up at the moment, but I'll show you guys how I would research. So I would look at the new Sydney Fish Market, and you can actually, since it's a big investment from Infrastructure New South Wales, they have heaps of information on the progress of it, and they have a lot of reports that are out. So if you look at Sydney Fish Market, for example, you can have a look here on both of these websites, and it will have a lot of information. So basically has all the project design, about the project, the actual construction timeline. All this stuff is really important, right? Because let's have a look at what time it would be at, what timeline it is on. So they're currently doing bridge road works continues. They're doing building structures, roof canopy, stuff like that. So you'll see a lot of machinery that can be used for those kinds of things, right? So kind of figure out what project you want to do a bit of research before you pick the project to see what stage they're at, because if they're finishing up, you're not going to see a lot of equipment as like an early stage project, right? You're not going to see the excavation, you're going to see all this other stuff. But yeah, just have a look at that. So yeah, all right, assignment. Anyone have any questions for the assignment still?
Oh,
Yes.
so they want photos from outside the job site. They don't want us to actually get on there.
Yeah, it's pretty hard. Oh yeah, because
We can get on.
Yeah.
But a lot of them, when we did our assignment last week, he was kind of encouraging people to get their white cards and enter it.
oh, okay. Well, okay. So when I did my site thing, he said absolutely no going inside the site. Right.
Yeah.
I'm not sure if that's changed. If you can, definitely go get your white card because that's what you need to enter a construction site. So get your white card to go in, and then you can take photos and stuff like that. But I would say on the outside of a lot of the projects, they have a big banner. By law, they have to have a big banner, and they write out who the site manager is and their phone number. Give the phone number a ring within business hours or text them, and you might be able to get in contact with the project manager or whoever's on site at the time. So yes.
What if the construction goes too slow that can cover several processes?
Oh, okay. Usually if the project's big enough, there will be a lot of things happening at once. Yeah. So even if it is currently all excavation, they're going to be doing some excavation. They're going to be doing some formwork, shotcrete, stuff like that. So you'll be able to kind of pick apart those processes. So yeah. But don't pick a small project. Yes.
Oh, another thing I'll add is don't be the dumbass today. So I went to go visit construction site on Sunday and nothing was happening.
Yeah. So usually construction sites operate from 6 to 6, roughly, more or less.
Sometimes the first half of the Saturday as well.
Yeah.
Well, it seems like a place that's close by. Like, find like a middle point of all your group members.
Yeah.
And then go. It makes it life a lot easier when you're like traveling and trying to find what days they actually have stuff going on.
Yeah. So, for example, like if you're living in the eastern suburbs, don't pick something that's in Blacktown. You're going to kill yourself by the end of the project because you're going to have to visit it 4 times. So yeah, definitely try to pick something close and PTable or drivable, whatever it may be.
I would say some good places right now are like the student accommodations in Kingsford. Like,
Is that 5 million? Is that above 5 mil?
Actually, because I know the apartment building that I did was over, and this is going to be more than that. Yeah, the skate ones in Kingsford, those are really good. Because it's on the right road, and there's a bunch of like actual construction that's going on right there.
Okay.
Yeah.
So you might be able to use that.
5 million just would be like if you went into your backyard and someone's house like being built next to your house. That would be 5 million.
Yeah. Okay. Another tip is if you do try to contact a manager, a project manager or project engineer, just be really respectful of their time. Those guys are under a lot of stress all the time because things are going haywire all the time on site. So try to contact them, give them a couple of days, and then they'll hopefully get back to you. But call them during business hours. That should be okay. But if there's something that's happening on site, for example, there's a concrete pour day that you can visually see, they're probably not going to pick up your phone call. So yeah,
very good. So we'll take a short break because we'll take smoko. We have heaps of snacks and stuff, and Josh will get ready to present the second half. What are the topics that you're going to be?
I'm going to be doing weeks 6 to 10.
You can get,
and that's all construction equipment, and like more of the production of those equipment and the economics, which is right at the end. In terms of like actual costs, so how you can efficiently maximize your smokers and stuff like that.
Yeah. Okay, but we have heaps of snacks. Feel free to grab some, go to the bathroom, grab some water. We'll be back in probably 5 or 10. And then,
Thanks,
the whole thing will wrap up.
No, don't forget the...
Do you have a lighter? You didn't bring a lighter.
Yeah, I have this. Okay.
Do you have some flint and steel?
Anyone like cigarettes?
Can we pass one of these to everyone? I want to take a photo. You don't have to.
Dude, have you seen my slides?
Yeah.
They're cooked. Wait, no, don't spoil it.
I'll probably go through this after the break, and then
no.
take over. Okay, sorry.
I want to like shut down their like hopes and dreams because I got the bell curve already. I've got the exam bell curve already, right? The slide right after this.
But if anyone has questions, feel free to ask me or message me on Messenger.
He doesn't reply on time.
I do reply.
It's like 3 business days.
Yeah.
I'll take it.
isn't sponsored by I get as well.
Quick help, right?
I'm a chain smoker. It's my career.
Yeah, the sticky for the boys. It's such a haram boy right here. He was found inside like a Dad Murphy's and everything. Oh wait, sit down.
This works first.
Well, that's so dodgy, man. Hey,
Should
take a selfie. Everything.
Yeah.
I'm pretty sure. It's 0.5. It's so.
Oh, like that?
Yeah.
Shit. Wait, that's so good. This is on 0.5.
What?
Sponsored. I don't know if I'm not more. Yeah.
Now for redheads.
Redhead, what's that?
The Mackies.
Oh. Alright. Everyone say Smoko.
Smoko.
Alright, buses. Okay, that's pretty much. Snacks. Everyone wants snacks though. Like, snacks are so fucking many of these. I'll just like drop and drag around. I don't think I'll just see.
Leah, how's your night? Oh, do you want this back?
If you smoke it, I don't want it back.
Tide Pods.
Yeah, I want some Tide Pods in my liver right now.
I wish I could. Man, where were you last night? Oh my god.
I was at my friend Brad.
Are we understanding it?
Skip
Okay,
locally
guys.
night. Yeah,
It's alright.
Dude, this is the first time I've skipped like 7 soccer matches. Today and tomorrow. I mean, yesterday.
I'm a dumb fancy. Yeah, everything's been fucking changed.
I'll put it back in the back.
Wait. Where's my phone?
Yeah. Oh, yeah, she goes through the back. Oh, it is a No. Oh, yeah, it's so funny.
Yeah, they responded to Aaron.
Saudi flag.
Take the filter in the back out. Hyper's gambling.
What's that mean?
Oh, yeah.
Thank you. And then I said this. Oh, you showed me.
Well, I didn't get
Yo, Clang, can you send me that photo, man?
Oh, yeah. Facebook or.
That goes.
Oh, yeah.
It's on the video. That's
Oh,
so
you
got the mini M&Ms.
Yeah, I know. Oh, you want so much better.
Actually?
Yeah, I think I reckon our William's going to go up this subject.
I think I know you're wrong.
Henry, are we sending these slides to people that are?
No.
No.
Yeah, we are. Let's go.
Because I think my section, they have a bunch of like example questions as well.
Oh, sorry.
But we might skip through them.
Oh my god, I can't wait to do 3101.
Yeah, we'll get you boys back through it.
So I've got a lot of information, even though some of them are like a little bit difficult.
Tell them
Yeah.
But
about
there
the
are
embezzlement.
good information.
Thank you.
No worries.
I'm an expert in that, bro.
Okay. Want to start?
Once they're ready.
Wait, can I just
Give them a few more minutes. You have to be somewhere at 1, right?
Fair enough.
You have to be somewhere at 1.
How do I know? Oh,
Dom started joining
no,
us.
Henry.
Oh, yeah.
He was just talk about
Yeah, I've got it.
like random things.
What slides
he
he
was
on?
teaching me about 3101.
He's on 38. I have to get
I saw the slider. Okay.
Yeah, I have to get to 82.
Yeah, correct. 3.
Okay.
But it'll be fine. It'll be fine.
We'll get them off Slackers.
Nah,
They're just chilling around.
Trust.
Oh, can I talk about this part?
Yeah, this is your part.
Okay.
Oh, yeah.
CVEN2101 ain't looking too good.
No, it's
Holy!
not.
Did you go for
Let me check the story.
today's?
The what?
Today or yesterday's? The one with statistics?
The lab one?
Yeah, using
That's
MATLAB?
cooked.
It was so stupid!
Bro, he did nothing, man. He did nothing on board.
Go on, spell it correctly. You spelled it incorrectly.
Oh, is it actually?
There's 2 M's.
What? Oh, shit.
Sorry. Sorry, blood.
In finals for CVEN2101, they wouldn't ask us like import like massive files, right? Surely not. Which is like one line of data, right? Okay, sweet. Because I know they code like standard deviation, plot, stuff like that.
Oh, that's good.
Not from importing like this massive.
No, they won't make you do that. Wait, it's fucking cooked. I hate that.
So lab was pointless basically. Right?
No,
no,
the labs are
they're
actually
useful.
good.
They're useful. They're
The
useful.
labs are good and they're just so fucking boring.
Yeah.
Okay.
But they're really good because. Like,
Who is it? Is it Ellie who teaches?
No, the guy that I don't know the guy's name, but it's a bald guy.
Alright.
Oh,
We're gonna start with
fucking Josh is sitting.
Yeah, possibly. Dude, he's gotten off his astronaut stuff and now he's a teacher. What are you laughing at, huh? Oh, I see. You want?
Alright, we're gonna get
What?
started against you guys. So,
Alright, Dom, take it away.
All right. I'm just going to talk a bit about the midterm. So this is probably what's coming up and what's most important. So this isn't a design course. So design course is mostly like a lot of calculations and stuff like that, where you do like, you're trying to design concrete or steel or something like that. You guys will do that in third year. But yeah, this isn't a design course, so it's mostly going to be like tradie maths, right? And what I mean by tradie maths is like adding, subtracting, multiplying. The main thing that gets people is that they do the wrong units or they multiply the wrong numbers. They try to find something that they're not meant to, those kinds of things. The calculations take a long time, but they're not hard, right? So they're super, super easy. If I can pass the course, anyone can pass the course. So yeah, isn't hard. The content itself, like the information part, isn't that hard, but you really need to understand like all the details and intricacies, right? So a tip that I would say is though, study a lot for the calculations, because Mosen, even though he teaches a lot of it as theory, most of the course is calculation based, right? Your course, your midterm or finals will probably be about 90%, 95% calculation basically. He might ask you a little bit of theory here and there, but that's just dots.
Last year, that got changed up. So
Really?
Yeah. So
Okay.
last year, in the course, he asked lots of questions about very, very specific terms that were actually in the lecture.
Okay. So there you go.
In saying that, like only like the last 2 or 3 questions were actually calculation ones. It was a very open book exam, and by open book I mean it was like open up your laptop, you can use that. You can't use the internet though. He was like he was walking around. What he did ask you to use were the slides from the lectures and all the workshops. Those were the only things you were technically allowed to open up, but obviously he can only watch like 2 laptops at a time. And depending on where you sit on the in the lecture theater, you might be able to get away with some stuff. But that's basically what I'm trying to say. I guess it depends on how he's feeling, how the exam might be set up. Another thing, as Dom's just explained, a lot of them are calculations, but we don't have any solutions for those calculation questions, like the practice one. So like the practice one, like this one, there are no solutions for it. Even if you go on to check it, you don't know if it's correct or not. And we can't actually check with him because he kind of like wants very specific, meetings to be set up with him to do that. And then he doesn't actually go through it in detail either. So you actually never know if it's correct or wrong.
Yeah.
So I guess the best way to like solidify your knowledge for this is just to do workshops. The workshops have solutions.
Yeah. But do it with your mates. Do all the questions with your mates. If you guys need the midterm paper from 2 years ago, feel free to hit me up. I'll give it to you guys.
Yeah.
Oh, can you add me to the 2101 thing? I'll add all the slides and stuff. Yeah.
Alright.
Okay. But yeah, I'll just go through this. This midterm question might not be relevant. I'm not sure because, as Josh said, there was a lot more theory now.
This one, there was a question like this. So this one will most likely get tested.
Yeah. So you can see that parts A and B, 3 marks is just tradie maths, right? So it's pretty easy to get the bulk of the marks. And then for the last question, it's only 1 mark, right? And you just have to understand, okay, on a site, what's it going to actually physically look like? Costing, stuff like that. You have to understand that kind of stuff. But yeah, that's basically it for the midterm and finals. So yeah, thanks, Josh.
Easy as, thank you. All right,
Take smoker now.
now it's my turn to take over. So based off of what he just said, what Mosen did do was show us a little bit of a bell curve of the midterms. So hopefully this doesn't discourage you. That was the bell curve. Most of us were between the 49 and 60 because of how unprepared we could be for all the calculation questions based off of the fact that we didn't have any solutions for it. But as I said, the terms that he used were very, very like select for all the theory questions, and they were like hidden in like pages and pages of the lecture notes. Like each week were like 50, 60 pages, and it's like a term that's found like once, and he goes over it for like 2 minutes, and then that was what we were tested on. And that because of that, and we couldn't use the internet to actually search stuff up, we were all getting a little bit bogged down in that and couldn't actually solve that question. Or we kind of like gave an answer that wasn't relevant, I guess. But that was the midterm. The finals, I believe, was a lot more fun, and it was a lot more doable, and I think it will actually like bring your marks up if it is kind of like lacking behind right now. So, lecture 6 is one of the only weeks where there is no calculations at all. It is all about the sustainability and digital engineering. So sustainability, hopefully you guys did DESIGN 1000. You talked about a triple bottom line. Exact same thing is talked about here. We have environmental, social, and economic. So the people, the places, and the money that's involved. Those three things are very important. They're talked about because obviously in every single construction project, you actually have to save money and think about the people that are involved as well. And think about the impacts on the environment. Yeah, that's the main things with the triple bottom line. On top of the sustainability aspect, we also talk about the digital engineering. So digital engineering is quite literally ways to see the project, but through a virtual kind of like existence. You kind of like put on VR headsets and sometimes and walk through the project itself, trying to find all the issues with the project before it actually gets constructed, so you can like save some money on it. We have geospatial engineering, we have BIM, building information models, Internet of Things, which I honestly do think is like a really dumb name, but the idea of it is kind of cool. You have immersive visualization, which is basically VR and augmented reality as well, and digital workflow systems. We'll be going through most of these, just really briefly. So what is geospatial? Well, you need to see the world through not just your eyes, but like through data. Data is more accurate than what we can see. Obviously, we have all the human aspects of stuff with emotions and how we feel walking through a space, but what does the space actually look like before it's actually built? And that's what geospatial is. They take all the data from all the construction that's happening, and they kind of like try and find areas that can be improved upon before it gets like expanded on, I guess, or they want to fix any issues without tampering with the actual stuff just yet, if that makes any sense. So that's geospatial. We use lasers for that, and it's good for scanning roadways, airport terminals, bridges, and mobile mapping, because obviously those are large distances, and human power for that would cost a lot, right? We also have BIM. So BIM is basically a big like life. It's got a life cycle, and you can see from this image, it starts from the detailed design, and then goes to the analysis, documentation. Then they start like constructing it, and then the logistics of it, followed by the operation, the demolition, and then the renovation, and that just keeps circling around. So every building obviously has a certain lifespan. It's not going to last forever. So what are they going to do with the building once it's abandoned? Well, obviously demolish it, and then how can they use that those materials in a very sustainable manner as well? It's good for improving planning, design, construction, and it's better for design in terms of visualization, collaboration, estimation of cost. And for fabrication. Now, fabrication is actually a very key point here, because obviously you want to make sure that things can be fixed before it's built, right? So how can we fix it before it's built? Well, if you can visualize it in 3D space that's not real, but rather digital, then, well, you can fix it at its root, I guess. Does that make sense? Yeah? Yeah? Okay. And it's also better for occupiers and managers because they can see the building being built in BIM before it's actually created in real life. Now, Internet of Things. We have a connection between physical devices and the actual buildings and, well, all the machinery that's around. Now, how do they do that? They have sensors that are connected to every single thing here. And if you guys have watched Avatar, you know how they get their hair connected to like one of those like animals, and then they feel like the thoughts of it and can see everything from that eye. Something similar to that. You're far away, you put on this VR set, or you get your computer and you're connected to all the sensors, and those sensors kind of like pick up on every single interaction that occurs. I'm just trying to think. There was something that he said last year about, oh yeah, a lot of the helmets actually also have sensors in it because it kind of tracks exactly where you go. So that means you can't just like stay in a spot for like 50 minutes on company time. So it's there to actually save money for the actual builders as well and the occupiers and not have people waste their time. You can reduce costs, enhance safety, security. Immersive visualization, this is the VR stuff. Well, you walk into, they have like QR codes like this around the site, and it's basically you scan that, you put on the set, and you kind of see what the space will be like once it's furnished and stuff like that. And you kind of walk around that area, see what can be improved, pass that on to the architect or the designer or the builder, and well, fix it before it gets furnished. And well, all the design aspects need to be basically saved there as well. It's good for communication because you can have multiple people in the same room, even though they're very far apart, as long as they've scanned onto the same code. And well, you can talk obviously through VR and everything like that. So it's like Ready Player One. You can actually kind of move around freely rather than just being stuck in a single space. So that was lecture 6. It is a very short lecture because it's the one that's right after the midterms, and he's kind of like just easing you into it again. But from here onwards, it gets very, very cooked real quick. So the next 2 lectures, 7 and all the way to the end of 8, it's all about the different machinery. Now, in 2101, we talk about excavation and loading, pushing and hauling machines, and finishing machines. We don't talk about tunneling and lifting because those are in a different course. So I'm going to go in order of all these. So there will be about 7 different things that we're going to be talking about. You're going to hear some noises at some times. When you hear that noise, it'll be the production. And the production is where the calculations actually happen. I have a few example questions as well. We might have to skip that, but we will give you these slides as well so you can like look through it. If the quality of the image is a little bit bad, it's because I screenshotted it directly from my Word doc because I'm someone that writes directly on paper. So I had to like transcribe all that into a Word doc and then screenshot it into this. So I apologize for that. So firstly, we have the excavator. It's an excavation machine and it's a very heavy equipment. Why do we need it? Well, its ability to work in confined spaces is really good. It can turn around. It's on the tracks and it swivels around, so it can kind of like reach all these hard to reach places. There's high flexibility in rotation, lightweight, causing low ground pressure, and ability to be adapted to different functions. So what do I mean by that? Each of the excavators and a couple of other machines, the actual digger at the end can be removed, and there's a different attachment that can be added onto it. So what are the types? Well, we have the hydraulic one. We have the shovel, which is one of the extra things that you can like remove and put on top to dig out larger areas. We have the backhoe, which is mainly for what? Versatile and excavation and loading, and it's used usually during medium-sized and residential construction. All these different applications or all these different things have very specific times they can be used. You can't use a long reach in a small suburban area, but you can use a long reach when you're trying to get to the very, very top of like apartment buildings. And when you get to the long reach, you can use like, I think Dom talked about it, one of the top-down methods. It's kind of like used together to bring down, to do demolition as well. We also, it doesn't come out from here. Okay, well if you ever hear that ding, ding, ding again, it's the production time.
Increase the sound effect.
On your account? Yeah. All right. Every single machine just uses these 5 letters or 6 letters, nothing else. But depending on which machine, you have a different combination of these letters. So for excavators, we have P is equal to CBSVE. So what is all of that? Well, I've got them all written out. Now, the reason I've got table 1, 2, and 3 is because now this is the one thing that really pissed me off about the entire course. They didn't provide us with the tables themselves. Now, for the final exam, it was an open book exam. But if you didn't bring in the lecture slides, or you didn't write down the tables, you're kind of screwed for a couple questions. So in my book itself, there are like pages of just the tables themselves. And what do the tables look like? Well, that's what they look like. It's a little bit cooked, right? There's a lot. But it's actually really, really easy to actually read, depending on the information that's provided to you. They tell you exactly what kind of ground that the excavator will be moving on. They tell you exactly what type of materials in that ground. And they tell you exactly how deep you want to cut it. They also tell you about the swing angle. And all of that is very, very important to actually solving a question. So I'll do one example with you guys. So that was a question right at the top. You write down every single variable like usual, and then you just multiply it. But the thing is, for the bucket volume, you have a 0.921, which means that there is a range of answers. You have to show the maximum and the minimum range. right? So therefore, it's from 0 to 9 to 1. You have a range of 234.9 to 261. And that's what you have to write as your final answer. Now, as I said, for most of these different equipment, I do have examples, but I won't be going through every single one. All right? Okay. Next up, we have loaders. Loaders are taking all the dirt, we're moving it into different areas. So it's used in construction alongside the excavators themselves, and it is ideal for confined areas because they are, once again, smaller scaled machines compared to other things that we might be going through. There are two types of loaders. We have the mini loader, which is big loader but compressed, and we have the grappler, which is usually used for timber and lumber. And it's really cool just watching it kind of like grab all the pieces and then like moving it around and tossing it somewhere else. If you've ever seen like those TikTok ads of the machines that go and like get the wood from like the rivers and stuff, that's what they're doing. Sorry, that was a little bit of a tangent. There we go. Another one, another production value. This time we're missing one of the letters from the previous one. I believe it was S. This time we're just worrying about cycles per hour, the bucket fill factor, the bucket volume, and job efficiency. What is job efficiency? It's just saying how many times can I do this job within an hour? Like how many cycles can I do, basically. Once again, you need a bunch of variables. And all that is in the table, which you do have to write down. If you don't write it down, well, I don't know how he's actually going to do it this term or this year. But last year, it kind of like screwed us over quite a bit. So yeah, this time the table worries about loose material, blasted rock, and just things that don't exist within those two specifically. So that's why it's under others. So moist loam, soil, cemented materials, rock dirt mixtures, and depending on what type of loader is actually used, it changes a lot of things as well. So what is the two different types of loaders? Well, we already know there's a mini loader and a grapple loader, but they can be either on tracks or wheels. Yeah, and depending on the soil that you're on, different bases need to be used. So here's another example. I won't go through it, but it's basic multiplication once again. Next, we can talk about dozers. Dozers are tractor units. So now we're done with the excavation. Now we're worrying about the pushing and hauling. So dozers are one of the most famous types of pushing equipment, or machinery, I should say. A lot of them, you see a big dozer in Bob the Builder. I think it was the blue one. But what are they used for? Well, you move the material out of the way. You can move it to the side. You can use that dozer to actually cut into the soil as well. And spread material. Spreading material is actually more common than you might think. You backfill, you can strip, topsoil removal, you can break up rocks because of the actual shovel itself. Oh, the blade, I should say. Now, with dozers, obviously there's the track and the wheel dozer. Wheels have wheels, tracks have tracks. But when are they actually used? Well, the wheels are good for pushing softer soils since they have lower traction and higher ground pressure. So they can like kind of stick on it and like push. But the actual track dozers are good for harder soils because they can cut it as well. And there's a higher traction because there's a larger surface area. And it's a lower ground pressure, so it pushes more soil over it. Now, on top of the wheel and the tracks, there are also adjustments to the blades themselves. The blades are the S blade, A blade, U blade, and C blade. C is cushion, U is universal, A is angled, and S is I forgot what the S one was. I have it written down. The S blade was, give me a second. Oh, the straight blade, who would have thought? It's just a basic blade, right? They use it to cut and just push stuff. The angle blade can actually shift angles and like push the dirt onto its side and then let everything else pass through. The universal blade is just longer than the straight blade, but it's for stockpiling a lot more dirt. And finally, the cushion blade is only used for pushing other equipment. It's only used for other equipment. It is quite a soft blade as well. Oh, look at that. We have CVE instead. So now we're missing another letter. B is not part of this. But there's a big difference because of the V this time. We actually have to solve for the blade load by using more math. And what's that math? Well, this is directly from the lecture because I couldn't be bothered to write it down. We got 0.375 times by the height, width, and the length. So it's basically the area times by 0.375. Height, width, length. the volume times by 0.875. And how do you find the width? What's the average of the two sides, and the height is the average of the two heights. I've got an example question as well there for just the blade load. So I've got my answer at the bottom. And then you also once again have tables. Now depending on the so cycle time is something else that you have to actually solve for, and the cycle time is the fixed time plus push time plus the return time. Now how do you find all of that? Well, the tables actually kind of like help you solve that question. So for the fixed time, it's always going to be one of those three numbers at the top, depending on what the question says. And the operating speed, well, the push and the return have different speeds once again, ranging from 2.4 to 4 kilometers per hour, which you have to actually base it off the question. So we have trucks this time, and it's the main equipment that's found in it's the main equipment that's found on these sites. It's used to bring in equipment, take away equipment, take dirt into landfill or other areas for dumping. Now, trucks actually have a lot of different variations. We have the rigid body trucks, we have the articulated body trucks. Rigid just means it can't move, like you can't actually like separate it. But the articulated means like the head of the truck is independent and is on a swivel compared to the tray itself. Think of it like Optimus Prime itself. When he turns, well, the truck turns with him, but it's not like they all turn at the same time. There's three types of dumping. There's a rear dump. Oh, I read rear dump. That's a typo there. Bottom dump or side dump. You can kind of guess what that is. Rear dump is through the back. Bottom dump is from the bottom of the actual tray itself, and side dump is the tray turns to its side, dumps all the dirt out. On road and off road, that's pretty self-explanatory. Oh, it's production time. CVE once again, but actually trucks and scrapers and a couple of the other stuff is actually a lot more complicated than the equipment that we've done so far. The reason being, there's actually a lot more that we have to worry about. So even though it is just CVE, the cycles is actually really cooked here. So a truck cycle time is the loading time plus the hauling time plus the dumping time plus the returning time. We had to solve for each of these individually. Now each of them have their own solutions. Like this. So the loading time is the number of bucket loads times by the excavator cycle time. Now how do you find the number of bucket loads? Well, you're getting another formula and putting it back into it, which was the truck tray capacity over the excavator or the loader's bucket capacity. This is once again directly from the lecture. You can simplify it however you want in your notes. The hauling time, it's all done in minutes. That's why it's 60 times while hauling distance over the hauling speed. Those are also two things that you need for the cycle time. Finally, the dumping time, it's always going to be one of these three, depending on the condition and what type of dump you have. Any questions so far? All right, easy. Scrapers. We're going on to the finishing equipment, I believe. No, it's still spreading. We're in the spreading equipment still. Scrapers are the things that kind of like plow through the ground. You might see them on farms. They like kind of till the dirt to make it a little bit softer, so it's easier to cut up and stuff like that. Cut soft and medium materials that are free of roots, stumps, rocks. They have open tops for loading and would require a dozer to help push the scraper for hard soils. So there are four types, sorry. The single engine, which has one engine. Then we have a double engine, or the twin engine, which has two engines. We have the elevating, which allows the thing to kind of like lift up, so it might be on a little bit of a hill that it wants to like scrape. And finally, we have the pull type, which has no engine at all, but it is using a tractor or something to pull it along the actual dirt itself. That's good for wet, soft, and sandy conditions. CVE. We have cycles per hour, which is what we have to solve once again. We have the scraper time cycle, which is the fixed time plus the variable time. And the fixed time is the positioning time plus the loading time plus the dumping time. Now the variable time is the hauling time plus the returning time. You need to get all this information, combine it together, get the actual answers. Once again, it's a little bit cool. So as I said, weeks 7 and 8 are very, very dense in terms of calculations. But the calculations are not difficult. They are not difficult at all as long as you have everything in front of you. Once again, you have 3 tables that you need to use, just like the truck. Just make sure you follow the actual information a little bit carefully there. Now, we have finishing equipment. So, the first one's a motor grader. It is a multi-purpose for finishing and grading the surfaces, and it progressively makes the cuts and ditches in the loose and medium soils as it drives. There are two types. There's nothing more than this, the rigid frame and the articulated frame. As I said, from the trucks, the rigid frame means that everything is together. It is one big unit. The chassis is set, and the articulated is kind of like split at one point, so it can swivel and turn easier. Yeah, like the bottom one. Now, for the production of this, it kind of changes for finishing and finishing equipment. It's not the same as using CVE or B&S. We actually have to solve for a few other things. So, what are the things that we have to solve for? Well, we have to think about the actual motor grader speed, the effective width of the actual motor grader itself, and the number of grader passes. So how many times does it have to go through this area to make sure it is actually finished properly? Yeah, that's a big difference. So it's 1,000 times SWE, all on top of the number of passes to actually find the actual production value of it. Now, rollers, I think this is one of the more famous ones as well, the ones that you guys can recognize pretty easily. There are 4 types of rollers, I believe, and each of them have different ways of actually compacting the actual ground and the dirt underneath. So what do they actually do? Compact soil, gravel, asphalt through impact, pressure, vibration, and kneading. There are different parameters which result in different optimal rollers. So how do these 4 different compacting ways work? The impact is the stress that's applied by dropping large mass onto a surface of soil. The pressure is a large amount of pressure applied slowly onto the soil and then released. Vibration, quite literally, it is vibrating, and kneading is it massages the actual soil, and then as it goes over, it kind of like flattens it out as well. What are the types of rollers? We have the vibratory roller, a sheep's foot, pneumatic rollers, and grid rollers. I don't actually have any images because I kind of did this at 12 in the morning, so I kind of wanted to sleep. Sorry about that. And one last time, we have one for production. We have nothing times 1,000, but we do have a T that's added into this, which is the thickness of the actual layer that needs to be compacted. Because obviously, dirt has a certain layer, thickness of the layer, and it needs to be flattened to a certain size as well. It can't just be too thick, it can't be too thin, it has to be just right so that they can lay other things on top of it. Once again, you do have tables for this, which you need to use. So the first one is suitability of compaction methods of different types of soils. So that tells you exactly what roller you kind of want to use. Then the second one, the second table, table 14, actually uses that as well. You're using those two in tandem with each other. Finally, table 15 actually tells you exactly how many number of passes you need and the thickness of the layer itself. All right, so that's lecture 7 and 8 done. That's all the equipment that we have to worry about. So now we have to worry about the actual economics. Now, obviously, you work through, you get the construction site done, but you actually have to pay the people some money. So how much money are we actually paying? Well, that's what we're about to go through. There are 2 types of costs that we have to worry about: ownership and operation. Now, the ownership is the one that takes the longest time because of the depreciation. So ownership consists of the initial capital cost, the investment or the interest, the insurance, tax and storage, and depreciation. All of these have different formulas once again to actually solve it, but the one that we'll be worrying about for week 8 specifically is depreciation. There are 4 methods of depreciation. Let's actually start with what depreciation is. The depreciation is just how much money the actual equipment, the value of the equipment, the value that the equipment loses over time. That's the best answer. Anything that's wrong with that would cause incorrect values for the depreciation expense, wrong end of period net income, wrong debt to equity ratio, and a wrong balance sheet. So ultimately, as I said, you could be an expert at fraud if you do it wrong. So I guess there's some win in this, but obviously you might get sued by the people that are paying. So the 4 methods are the straight line, sum of years digits, the double declining balance, and the modified acceleration cost recovery system. Now, depending on the question, they will tell you exactly which method to actually use. It is very important that you actually keep to using that method, because if you use the wrong one, you'll get a wrong answer. So the first one is the straight line method. I'm not going to go into too much detail because hopefully you guys have all done like basic year 10 math, I think, where you use like some basic depreciation stuff. So the total depreciation is the initial capital cost minus salvage value minus tire cost. That is the one thing that will be repeated in all the different types of depreciation methods. The actual method will change for each of the four methods. Oh, sorry, the formulas change for each of the four methods. So what I've actually done when solving these, I'll show you one as an example. So we have the straight line depreciation method as a question, and we also have a table that I've written up here. The first thing we actually have to solve for is the actual annual depreciation. How much is lost every year? Well, remember what I said, the initial value minus the salvage cost minus the tire cost, which is found right over here, which means that every year it loses $12,000. Yeah, every year is 12,000. So that's why this middle column is always 12,000. Now for the book value right here, you've got the main cost minus the salvage value. The tire value, and then you minus the depreciation per year, and that is your first book value. Yeah, that is your first book value. And then from there, you just subtract exactly what the depreciation is, all the way till you get to the final value, which is 6,000. Now this 6,000 has to match with the salvage value that's in the question. If it matches, that means you've done it all correct. Yeah, that just means that you've matched everything up, and that means your calculations are all good. And, well, that's the straight line method. We'll move on to the next method, which is the sum of years digits. So this one is a little bit confusing. I actually didn't like this method. What it is if you're asked to solve for the salvage value of, let's say, an excavator that's been in use for 5 years, you have to think about which year it is. So let's say it's year 1, right? You would have to actually use the digit 5. It goes in inverse order. So year 1 is 5, year 2 is 4, year 3 is 3, year 4 is 2. Yeah, 2, and year 5 is 1. Yeah, it's just inverse order. And that is something that he kind of like drills into your head when you do this method. So, once again, years, digits, divided by the sum of the years. So the sum of the years is always going to stay consistent. It's just a digit that changes depending on which year you're looking for. Once again, the depreciation is the initial capital cost minus the salvage value minus the tire cost itself. And, well, N is the equipment life. And, yeah, that's that. It's non-uniform. So, another example, we have the sum of the years digit. The depreciation changes every single year. So, how do we actually solve for it? So, D1, remember what I said? If it's the first year, you use the digit 5. We've got 5 divided by all the years digits added together. So, 1 plus 2 plus 3 plus 4 plus 5. Times it by 75,000. Now, where do I get 75,000 from? It is quite literally the main cost, the initial capital, minus... I should say 15,000. Sorry, I'll correct these slides slightly later on. The salvage minus the tire cost as well. You get 75,000 as your start point. That is what you want to multiply every year to actually get how much the depreciation is. So that value times 75,000 means my depreciation from year 1 is going to be 25,000. So what is the book value? It's the initial cost minus the tire life minus the depreciation, which is 65K for book value of year 1. Then book value of year 2 is minus 20K because the depreciation is 20K. And then we keep going until you match the question with 15K, which is exactly what the salvage value in the question is. That's the second method. The third method is the double declining balance method. Now this one's actually really, really simple. 2 over n will solve the question immediately because all you have to do is, let's say it's a 5-year thing, 2 over 5 is 0.4. You multiply that by the book value of that year. It does not automatically reduce equipment's book value to salvage value at the end of the year. The final year actually does need adjustment. Now what do I mean by that? You're going to see an example of that once again. So, as I said, we have the 0.5 over here. 0.4 times by whatever your book value is. You have all those values. But in the final year, the book value is 6.2208, which is highlighted in yellow. But if you look at the question, the salvage value should be 8,000. So obviously there's a missing amount. So what do you have to do? You just have to adjust the final year so that it hits 8,000. So instead of doing 4.1472, you manually change it. You quite literally change the numbers so that it just hits 8,000. That is the only difference for this one. It's pretty straightforward there. Everything else is just multiply 2 over n times the book value, you'll get the answer for every other year. You just have to make sure that that 8,000 is reached somehow by manually changing it. And the final method that we have to worry about is the modified acceleration cost recovery. Well, Cn is the depreciation coefficient, and that's where you actually, I believe you're given a table once again. Yeah, these are the tables. So it's, depending on the question, they'll tell you it's either a 3, 5, or a 7-year cycle. And in year 1, let's say it's a 5-year cycle. In year 1, I have to use the coefficient of 0.2. In year 2, I have to use the coefficient of 0.32. In year 3, 0.24, all the way to year 5, which is 0.08. All of those coefficients have to be used. You can't just choose one and then do the entire equation with just one. You have to use all 5 of them, or 7 of them, or 3 of them, depending on how long the equipment is actually used for. So one final example. Calculate the book value at the end of each operation year for a loader. So just based off of the table that's previously given, we know it's 5 years. So we're using the middle column. Can I go back? Okay, I can't go back. Well, I've written out the coefficients anyway. 0.2, 0.32, 0.24, 0.16, and 0.08. And the total depreciation is 120,000 minus 18K, which is actually 15% of the initial capital cost, minus the tire cost as well. So it's 95,000 as my total depreciation. So year 1, I used that coefficient times by 95,000 to get 19,000 as my depreciation for year 1. So for the book value, remember, it is the initial cost minus the tire cost minus that depreciation. Yeah? You get 94,000 for that first year. Then the second year is 30.4, so you subtract that, you get 63.6, all the way to 18K, which will, once again, match with the 15%, which is a salvage value, which is also 18,000. Make sense? Everyone's all good with that? All right, last thing, this needs to be remembered, like a big note. The first year's book value is the initial minus the tire minus the depreciation. Yeah. What you're doing when you're subtracting the initial minus the tires minus the salvage is finding the total depreciation. There is a difference between the two. Okay, so that's all the 4 depreciation methods done. Now we have to talk about the other 3 things, which is the taxes and storage, the investment cost. That's all under ownership, but they're really easy. They're really straightforward. Once again, very simple formulas that you have to kind of write down, and then based off the information that's provided, you just solve it. This first formula at the top, P is equal to IC times N plus 1 plus S into N minus 1 all over 2N. That is very important. That will come up quite a bit in every single one of the ownership costs that we have to solve for. Once again, this will be sent to you guys, so you can use it then. So the first one is insurance, tax, and storage costs. That's quite literally pretty straightforward in what they are. Insurance, percentage of your total cost. Tax is well, how much you actually have to pay to the government, and the storage is how much it costs to actually keep the equipment on site or inside a little like, what's the place called? Kennards? Yeah, like a storage unit. That's the one. You have to use the P is equal to so-and-so for all of these. Oh, did I forget one? Oh, no, sorry. This is investment. This was ITS. Okay. So we've just gone through all the 3, just using those formula. All right. So now ownership is done. Now we have to think about operation costs. Operation cost is the second half of, well, the economics. It's also pretty straightforward. All of these 6 things have their own individual formulas that you have to kind of write down, remember, and solve for in the exam. Fuel cost is the first one. You have to use another table. I apologize, but it is what it is. We have horsepower that we have to worry about, time factor, fuel prices, percentage of operation conditions, and the fuel consumption rate for different operation conditions. That is what you use the table for. Yeah. So as I said, you'll have favorable, average, and unfavorable conditions, and based off of which equipment you're using, you'll have a different coefficient that you have to solve using. Service costs, exact same thing. They have a small table, but you have to just, once again, solve for the service cost based off the information that's provided. I have one very big example right at the end. that I won't go through, but it is there if you guys want to actually look through the steps to solve one of those big questions at the end of the term. Same thing for repair costs, but this time you have a range. Remember, the range is really important. You have to give a small range and the large range, and the smallest value and the largest value, and show that your answer lies between that range. Yeah, that's repair costs. Tire costs, very simple. You have a price of set of tires. You have the expected tire life, and times it by 1.15. It tells you how much money per hour that the tires actually are valued at. Special items, so this could be things like replacement items, or the teeth on a excavator, or even the attachment itself. There is a very specific cost for that, and well, you have to include every single one of the special items that are included. If you don't, well, if you miss one, let's say, you're gonna lose the marks there. And finally, that's all the actual ownership and operation costs. We had to talk about buying, leasing, and renting. When do you buy, when do you lease, and when do you rent? Well, I've included all the advantages and disadvantages. There's quite a few directly from the lecture itself. We kind of really quickly glance on it. We don't actually go into a lot of detail about it because it is at the very end of lecture 9. And we were very lucky that he didn't actually test us on it. So just include it in your notes. Just have it there just in case they ask you, hey, if you're trying to get an excavator, would it be better to buy it? Would it be better to lease it, or better to rent it? To see how you can maximize your money saved or spent, I guess, depending on what you want. So that's all these three. I've had that in the end of the slide. And here's the big practice question. So that's the question itself, but they actually provide you with every single variable. Every single variable is actually provided to you, but there are something that are missing, and that's actually found in the actual question itself. So, how do we actually solve this? Well, we have 5-ish minutes. So, let me break it down. Oh. Firstly, enjoy this. There. And then we go on to the actual question itself. So, we had to split this up into the operation and the ownership costs. The ownership is one half, as I said, and the operation is the other half. So, I've got the left side, your left side is the ownership, and the right side is the operation. So the question is actually broken up into 3 sections. The first one is, what is the total cost of ownership and the total cost of the operation. The second part is the combined cost. And the third part is, how long would it take to actually complete the entire thing. So you can see that I've split it up into 3 sections: the investment cost, the ITS, and the depreciation. The method that was actually mentioned to us in the question was specifically the inverse order, right? So the sum of the year's digits. Yeah, so as you can see, the first year is going to be the value of 6, because it's a 6-year project. So 6 over whatever that total is, times by P, times by the actual cost of it, you get $60,857.14 a year. Then you find the actual investment cost, which is $10,937.5 per year. And you find the individual, the insurance, tax, and storage costs as well, which is $9,375 per year. Add that all up, and you divide it by the number of hours that they've actually asked you in the question, which is 2,500. And you get a value of $32.47 per hour just on the ownership of all of the equipment. Now, the operation of the equipment, same thing. As I said, they've given you all the formula, they've given you all the values. You just have to make sure you look at the table correctly. Follow all of that, you'll get to $57.59 per hour. You add the 2, so that means the operation plus the ownership, the O&O costs, are $90.06 per hour. So that's the first 2 parts done. We've just figured that out. Now, how do we do the third part? Well, there is a 60% overhead cost and profit. So you multiply that by 1.6, which is 160%. You get $144.10. That's just as a leeway, just in case something actually happens, right? Now, you divide it by the 50 LCM per hour, which is actually in the question once again. You'll get a value per LCM, which is $2.88. And finally, the total product cost is 10,000 LCMs. You multiply that by 10,000, you get $28,000. So at 8 hours per day, at 50 LCM per hour, 10,000 divided by 50 times 8 gives me a value of around 25 days for the entire thing to make sure it can get completed after the 2,500 hours. That is basically the end of the thing up. So we have Dom and I, thank you guys for joining us. Sweet. Yeah, that's the 201. Obviously, we don't get paid for this, so yeah, we're going to thank you very much.
I love the audio aspect of the
thanks.
presentation. It's great.
You're welcome.
So we'll stop the recording now. Basically, just a few